Good afternoon, everybody, and welcome to this, our 12th of our Circular Economy webinar series. Today, we are going to be listening to my good friend Dennis from the International Atomic Energy Agency. And you might be asking yourselves what atomic energy has to do with plastics. And we're about to find out. I was very interested by it, and I hope you will be too. So a little bit about our webinar series and the ongoing activities. This is part of our regional efforts to develop circular economy knowledge and share capacity building around the region. As I mentioned, this is the 12th of our events, and I do encourage you to look back into the archives and look at the many interesting activities and interesting projects that we've had available, and we've had speakers deliver on. We're very much looking forward to continuing this webinar series. So again, please, if you have technologies, if you have projects or activities that you would like to share, we're very happy to accommodate you from all over the world and share it amongst our regional partners. So let's look forward to our activities. And Dennis, I can perhaps hand over to you at this point, and you can tell us a little bit more about yourself and your project. Thank you very much.
Thank you, James. Colleagues, it's a great pleasure, first of all, to be together with you today. So thank you very much for inviting me and my colleague Petra. Unfortunately, Petra won't be able to join us today due to the urgent duty trip to Indonesia. So I'll also be speaking on behalf of her. But we are working together on the project, so I hope I will be able to present it reasonably. My name is Denis Subotnitsky, and I'm, as James said, from the International Atomic Energy Agency. And I work in the Technical Cooperation Department. In TC, I'm working in the Asia and the Pacific Division, and I'm the program manager for the project on plastics that we call NUTEC. And basically, to inform you about what we are doing in the area of plastics, plastic recycling, marine plastic monitoring with the use of nuclear technologies, the topic of this webinar. So I hope that I will be able to explain during my presentation to actually reply on the question of James, what is that we can do together with the ADB, and what are we doing in this area, like from the side of the agency in the area of plastic pollution. I'll just share my screen now and show you some slides for my presentation. I hope you can see it now.
Yes, Dennis, we can see that well. Thank you.
Perfect. Thank you. Cool. So the project and basically it's not a project, it's a large initiative, one of these three strategic initiatives of the IAEA that are currently implemented under the instruction of our Director General, Rafael Mariano Grossi, is called NUTEC, Nuclear Technology for Controlling Plastic Pollution. In short, so this is, we call it NUTEC. This was launched in 2020, and together with two other initiatives, Zodiac on zoonotic diseases and also Rays of Hope on cancer treatment. NUTEC, its purpose is basically twofold. First, to find the ways to increase the share of plastic that are being recycled when we are talking about petroleum-based plastics now. So this is how we are trying to use nuclear technology to basically update, increase, and change the way that plastics are being processed nowadays. So currently, most of them are not being reprocessed and basically just go to landfills, no use of them anymore. And the second point is to understand what happens to plastic afterwards if they are not recycled. And this is about marine plastic monitoring. So we are trying to understand where plastics go when they go to the ocean, what happens and how they basically we're trying to trace the ways they go through the oceans, through the currents, globally. This is the way to understand what is going on so that we can better do and understand what to do, like, and reply on the question how. A few words about NUTEC. So basically it's divided into two components, upstream and downstream. And the upstream block is on plastic recycling using the radiation technology. This is the block that is under my responsibility. I am the program manager for the project that is responsible for this component in Asia and the Pacific region. And the second block is downstream component. It's about marine monitoring of microplastics using isotopic tracing techniques. So this is with Petra, basically a colleague of mine. So usually we have two people in each region because obviously it's implemented not only in Asia and the Pacific, working on these two blocks for NUTEC. NUTEC includes two main sub-components like administratively. So first, in order to conduct plastic recycling with the use of radiation technology, increase the share of plastics, understand what's going on, for this we need quite a lot of research, and at first stage we had a lot of coordinated research projects. So this is the mechanism implemented by the IAEA when we get the scholars globally nominated by their countries, and we try to conduct necessary research to understand whether the technology is in principle feasible, so whether we are moving in the right direction. And the technical cooperation projects. So this is already more practical phase, and this is ongoing now. And this is basically what I'm working on. First, I would like to say a few words about the downstream activities. So about marine plastic monitoring. At first, a few words about what we know and what we need to know. When we started this initiative and the Director General of the IAEA launched it, the idea was that based on our estimates back then, by 2025, there will be 1 ton of plastics in the oceans per each 3 tons of fish. So which is in principle quite an insane, like staggering number. And if this trend would have continued by 2050, the number of fish would be the same as the number of plastics in the ocean. So the oceans would gradually become completely devastated, like they filled in like landfills just with plastics. And that would have devastating results for the marine ecosystems and as a result for all of us, as we live on the same planet with the inhabitants of life underwater. For this, in order to address this global challenge, our Director General has decided to move forward. So what we know at this stage, based on previous research and research that we conducted during our experimentation, that marine microplastic particles are basically everywhere. Yeah, so they go to the oceans mostly. Yeah, like when we use plastics, they go to landfills, then they somehow get to the water, then they disintegrate, and those microplastics remain in it. But then they also not only remain there, but they also in air, water, dust, and as a result also in the food that all of us consume. So it's not only the approach of morality that we want to protect fish, for example, in the oceans, yeah, but also the issue of global health, because all of us will be consuming more and more plastics, microplastics over years. And this will have clearly the consequences for our health. So this is why this challenge is so great, I would say. Yeah. So this is why we somehow need to face it. And I'm glad to be involved in this from the side of the IAEA. Plastic toxicity is site and exposure dependent. So yeah, depending on the type of plastics, they disintegrate in a different way. So some of them are micro, like so 10-6 scale particles. Some are nano, 10-9. So and whatever we consume, whatever fish consumes in the ocean is the combination of all of that. Many marine animals and even humans ingest microplastics, as I already said, and this trend will only continue unless something is being done with us putting plastics in the oceans through the use of due to our industry and consumption. A few words about our activities here in Asia and the Pacific. So for the project on marine plastic pollution, we have all IAEA member states in Asia and the Pacific being involved. So obviously it is not the concern only of Asia and the Pacific, but this is the focal area for the agency in this field, because most of global industry is located here. So like very significant share of plastics are going to the ocean in Asia and the Pacific region first. And second, very significant seashore, yeah, in Asia, and a lot of island states. So this is why it's particularly important for Southeast Asian countries. So near half of global plastic leakage now comes from this region. And this is why we find the solution in East and Southeast Asia that should have tremendous impact on our efforts globally. What the agency is doing? So we have laboratories in Monaco. As James said, we are located in Vienna. This is our headquarters and where I'm talking to you all right now, but we have offices in other parts of the globe, and we have a very big directorate of the IAEA located in Monaco. It's marine laboratories of the IAEA. They exist for decades, and they're one of the most renowned globally in the field of research on the oceans. So this will potentially should become like one of the centers of our activities globally, because I will be telling you what will be what is the plan further, and like this will be the center of our network potentially. And we also have radioecology laboratories that are using radio tracers, and this is how we are trying to understand where the plastics go, and how the currents work in terms of plastics, how they spread around those currents due to their stream, how the impacts of plastics, by the way, impact on how they spread in the oceans and so on. Oh, this activity broadly falls under the umbrella of Sustainable Development Goal number 14, life underwater, that clearly involves others, yeah, like including human health, for example, or food for everybody, and so on. But the particular aim of the project that we are implementing on marine plastic monitoring in Asia and the Pacific is to enhance the understanding of the abundance and impact of marine plastic pollution in Asia and the Pacific region. And also we are trying to improve plastic management in the region through the establishment of baseline surveys and the status and trends of marine plastic pollution impacts. So these are the countries that are involved in our activities. And they are all committed to the report on Sustainable Development Goals, particularly on SDG number 14, life underwater. The member states that you can see on the map are engaged with the topic of reducing plastic pollution strategy, regulations, and national and regional projects. Now we are coming to practical part. Basically, what we are doing in the downstream block of NUTEC, particularly in Asia and the Pacific region. So we have strategic approach that consists of four main components, four main stages. And we are for each of them, we have some deadlines, and we are trying to follow them to reach the final goal. At first stage that started in 2019, right before the Director General of the IAEA officially launched the initiative, it's the stage of the development of harmonized protocols, so the stage of capacity building. The idea was that all the member states involved in this activity would develop the harmonized protocols, how they conduct research and how they monitor plastics in their territorial waters. So the reason for this is that we would like to use the same methodologies and same approach to collecting data in order to make all this data conformable, and that would be able to integrate it in the databases. Because you can have really good researchers, really good laboratories, but in case if you have the data that is not conformable with something else, that would not work. Yeah, it won't be useful to have one methodology, let's say for Vietnam, and then another methodology for India. If the data that is being collected and how it is being analyzed is different, that would undermine the whole initiative. So this is what we are doing now, and we are very well advanced with this project now, this stage. At the second stage that started basically right after the initiative was officially launched is the transfer of knowledge. Again, connected with capacity building. So what we are trying to do here is to transfer the information in the countries that are a bit lagging behind in their laboratory capacity, the skills of their force, yeah, like even when we are talking about Asia and the Pacific, this is a huge region, yeah. So clearly, countries are at very different stages of development. This is why we are trying to put them more or less at the same level to extent possible, and particularly those who do not have enough capacities to support them. And this is where the role of agencies, the UN organization plays, I think, the most important role. The stage number 3 is the establishment of a reference laboratory in Monaco. So this is what I meant when I told you that Monaco laboratories that are conducting research for the agency in about marine environment, about oceans for many years, will play instrumental role. So basically, the laboratories in Monaco will become like the center of our work globally. So they will be the reference center, the global integrating mechanism for all laboratories in the member states. So we are now moving toward this. This stage started this year. I think within the next 2-3 years, we'll have like a separate and very advanced laboratory there that will be able to provide necessary support, collect data, and also analyze this data in Monaco. And finally, at the stage number 4, that will probably take a few years, it's the construction, the development of a network of laboratories in the member states. Yeah, so we are trying to provide necessary knowledge, in some cases with the countries that face more significant difficulties with their financing, with their level of development is kind of limited, to provide them with necessary equipment. So this is also something that we are trying to do, so at least they have basic capacity to analyze the situation with plastics in their territorial waters. So because the stronger we are in each country, the stronger we are globally. So if we have like these holes in our system of global networks of laboratories, this will make the whole modeling, the whole understanding of what's going on with the marine plastic pollution significantly worse. That is why it's so important to support the countries that are lagging behind. And this, I would say, is the critical challenge for the project now. That's what we are really trying to push forward. Because clearly some countries will already have very advanced laboratories, and after we have harmonized protocols in them, in principle, we are fine. Yeah, so they can be integrated with the work with our reference laboratory in Monaco, like quite easily. A few words about our project, the regional project on marine plastic monitoring. So what is going on for each of these 4 stages? So about the establishment of harmonized protocols on microplastics. So the development of the draft protocol with harmonized manual procedures was done basically by July of 2022. So for this draft, there were expert group meetings. One of them was in November of 2022. The idea was to finalize the protocol, to agree on its details, particularly on the sampling and the ways the data is being analyzed. And then the meeting with all counterparts to review and endorse the protocol is planned in Q1 2023. I think it actually has already been conducted by Petra and her team. Upgrading the environmental monitoring laboratory capabilities. So this is an ongoing process, and what is being done under this project is provision of the kit of sampling for basic analysis. So each laboratory has the standardized combination of sampling materials, some equipment that they can use to collect at least some basic data. Obviously, we cannot fully equip each and every laboratory in the member state, so we need to be sort of efficient in how we use our funds. And then training activities. So we're organizing regional training course on strategies and design of macroplastic monitoring programs. It's collection, preparation, identification, and counting of particles. So this is the idea on how we increase the human resource capacity in the member states. So get people from all the laboratories in the member states that have been involved in the project and try to train them on how they should design their programs in order to be the most efficient over the next years in our efforts to understand what's going on with plastics. So this is planned by the middle of 2023. And then in terms of engaging partners and establishing the network, we are working on this. So Petra and her team are working on the development of communication products, the dedicated website on this, and so on. As you can see, I'm not talking here about particularly the IAEA laboratory, but it is under development, just not under our particular projects. It's under the responsibility of our directorate in Monaco. So they are upgrading and creating this laboratory as the reference one right now. A few words about the way forward. First, I think that's, and I here completely agree with my colleagues, is about early engagement between science and policy. So we are really trying through our partner laboratories, like laboratories usually belong to the ministries, to inform the national stakeholders, national decision makers, particularly the ministerial level, about what we are doing, what the science says, and like to get to the necessary policy support for those laboratories so that they function efficiently and get necessary support and potentially funding from their countries. Then we are trying to optimize and sustain the regional network. So this is why these regional meetings, coordinated projects, coordinated activities are so important. It's also to put people together, that they know each other, that it makes the exchange of data and joint work on its analysis easier and more straightforward. And collaboration among organizations to ensure the use of resources and the complementarity of results. We are trying to avoid duplications basically here, so that the countries that are getting near each other, they do conduct research on the same part of the ocean, and let's say one country works in one part, another is in another, so that we get more useful data. So this is the whole approach. Again, our resources are not unlimited. So in case if we do duplication, that means that we're doing less work in something more important potentially. So we also explore and try to forge formal cooperations with institutions and stakeholders on the national level, regional level, and with global initiatives, including the United Nations. So in the regional level, clearly, one of the reasons for me to speak in front of you here today is also to seek the ways for us to enhance our collaboration. So again, for agencies strategic initiative, we do what we can. We are fully committed, and a lot of our member states are committed as well, including our donors. But alone to address the challenge of plastic pollution globally, I think it is not possible. So this is why we are proactively seeking for partnerships. And like, I think ADB could be a great partner for the agency in Asia and the Pacific region. And this also falls under the Sustainable Development Goal number 13, Partnership for the Goals, because I think otherwise we won't be able to achieve the Sustainable Development Goal number 14. Now a few words about the project that I am the program management for. It's NUTEC Upstream. It's about plastic recycling. So just a few words on the background. In principle, logically, this is like the other side of the coin of this medal. So when we are trying to understand what's going on with the plastics in the oceans, it's the question of what is going on, like, and just to understand the scale of the challenge that we are facing. And my part of the project is the question how. So what we do after we understand what's going on with the oceans, when with the amount of plastics unstoppably increasing, how do we address this? What we can do about that? About the plastic waste management globally. So 79% of the plastics are just accumulated in landfills, dumps, or in natural environment. So like after you use something plastic, then you throw away, and just around 80% of this, so 4 out of 5 grams of plastic, they just stay on those fields. Nobody's doing anything with them. So 12% are incinerated, okay, and 9%, less than 1 out of 10 grams of plastic, like being produced and used globally, are recycled. So this number 9%, I think, is pretty shocking, yeah, if you think about this. So what we are trying to do here with the use of our technology, with the use of nuclear technology or radiation, is to increase the share so that more plastics are being recyclable. There's quite a lot of plastics, and I'll be talking more about this later in my presentation. They have pretty specific properties, and after they're being used, when you recycle them, the properties of what you get are not conformable with what was with original plastics. Yeah, so this is why it doesn't make sense to reuse them. So in case if we are able to change those physical and chemical properties, more plastics would be eligible for recycling. So more plastics would be possible to use in, let us say, for the production of construction materials, furniture, whatever, and this would be recycled plastics. So the maps that you can see were designed by our partners and also by the agency staff. We are trying to understand where most of the plastics are being accumulated. On the map down, you can see that it's mostly all in blue in Asia and the Pacific region, and particularly near the ocean lines. So this is where most of plastics globally are currently being located. A few words about, this is the map for the value chain, so how it works. So 99% of plastics currently are oil-based, yeah, so only 1% is biomass-based. This is why the main focus of our activity is on oil-based plastics, petroleum plastics. When we produce plastics, they go to manufacturing, then we use them, and then at the end of life, this is what is relevant to our project. Some are being recycled through mechanical recycling, some are being reused. So this is a very small part. And some go to chemical recycling with the use of catalysts and solvents. And this is where we are basically trying to get with the use of our technology. You can also use additives for chemical recycling, trying to enhance their property. This is one of the ways. With thermal treatment and mostly landfill disposal that I was talking on previous slide, and leakage to the oceans. So the first block of our project, the first block of NUTEC on marine plastic monitoring. Few words on NUTEC in Asia and the Pacific, particularly about plastic recycling. So our project basically is focusing on radiation modification for the production of industrial goods. So for this project, we have 10 countries in the region being involved. And out of those, we have 4 countries that are the pilot ones, so the countries with the most advanced program. These are Philippines, Indonesia, Malaysia, and Thailand. So other countries, they are more at research phase, but in these countries, we have advanced laboratories already that are being operational, and they are very advanced with the development of their technologies. The objective of this activity is to strengthen regional capabilities in the application of radiation for developing value-added new materials from waste, polymers for industrial applications. The approaches that we use are based on different types of reactions that you can achieve through the use of irradiation. So the map is below, like the schemes: cross-linking, grafting, oxidation, and scission. So these nice schemes, like demonstrating what happens to the polymers, yeah, how we cut them through the use of nuclear technology, was developed, by the way, by the team from Philippines, by our colleagues in the laboratory who are working on different types of these reactions for plastics in their country. Why radiation? Why our technology is useful here? Why basically we jumped into this? Again, the answer to James' question that he made in the beginning, yeah, like when you think about IAEA, I suppose you mostly think about safeguards or about nuclear power plants, something like this, potentially maybe about cancer. This is one of our main focuses of our work, but not about plastics. So why we jumped into this work? Why it's now such a big priority for us organizationally? Because radiation can alter the structure and properties of materials in various forms at moderate conditions. So by moderate conditions, it means that we do not need very high temperatures, for example, when you try to reprocess plastics. So you work at the normal temperatures, just like with the radiation technology. And this could be a game changer, because for high temperature, you clearly need very specific production conditions. So in case of the use of radiation, it can make the whole work much easier. Yeah, so like you can do it in much easier conditions. So in many countries that cannot secure high temperature, very advanced industrial capabilities, this could make the plastic recycling possible also for countries that are a bit lagging behind technologically. Also, radiation can synergize reactors. It saves energy with little to no additional chemical reactants. Yeah, so you do not need to add those additives that I showed on previous slide. So, and you use significantly less energy. And in the world that faces energy crisis, this is again a critical challenge. So we can use also a few different reactions. Yeah, like those 4 that you can see on this slide, you can combine them, and I'll also talk a bit more about that. The idea for the countries, the pilot ones with the most advanced programs, is that they all have their own research projects. So they deploy and combine different approaches to polymers recycling. And for the basic difference for this is that they use different types of reactions used for technologies under development. So, and you can see that some of them use only 1 or 2 types of approaches, yeah, oxidation and scission, but let's say Philippines, Indonesia, and Thailand, they deploy cross-linking, branching, and also grafting. Yeah, so, and Indonesia and Thailand also use oxidation. So this is a sort of a difference in the approaches. And this combination also has some synergetic effect. It makes their research and potential results more and more impressive. Again, a few words about our strategy here. So same approach based on 4 stages, 4 steps of activities under upstream block of NUTEC Plastics Initiative. So again, the first block is capacity building. So to try to support the member state to build their capacity. The second block that basically started from last year is verification of proof of concept and economic feasibility. And here it's quite different from marine plastic monitoring. So in this case, we are basically trying to conduct research at first in the laboratories and then verify that really the technology, the technological process being developed in each of these 4 pilot countries, Philippines, Thailand, Indonesia, and Malaysia, is working. So it's feasible. So after this, and the feasibility here is that the physical and chemical properties are significantly improved. And this level of improvement also depends on national regulations. So let's say in one of the countries, you have pretty specific regulations about the construction materials, and currently recycled plastics do not fit in those regulations. So you cannot use recycled plastics, let's say, for construction. But after the use of the technological progress, we are getting the materials with better physical properties. So they are more durable, they are stronger. And in this case, they potentially can be approved by the government to be used in the construction. And in that case, especially if we are economically efficient, there will be significant demand on the market. So to continue construction. And in this case, if we have more demand, there will be also the need and more supply of recycled plastics. So this could stimulate the development, the upgrade and expansion of the whole industry. So this is basically what we are trying to do here and now. The third stage, after we have verified the technology, would be to construct the pilot plants that will be operating with the use of irradiation-assisted plastic technology. So basically, the new or already existing but refurbished plants that where the necessary equipment will be installed and where the recycled plastics will be irradiated, changed, and then also used for the production of useful materials, equipment, and so on. And finally, the idea is that after we have those pilot plants and the industry will be interested in that, to go for upscaling and commercialization. And here, basically, it's 4 stages, but at that stage, it clearly will become very high level. The partnerships will be very important. So the role of agency there already won't be in the construction of the plants, I suppose, because we are not a commercial organization, but to try to get as many partners on board, and so that more plants like this with the use of technology will be constructed in the involved countries. For the whole project, particularly in Asia and the Pacific, I deployed the following approach that is built on these 4 stages that I talked about before. So it's called technology readiness level. So this methodologically, this approach is based on NASA. So American NASA developed this approach in 70s, 80s for their research programs for the aerospace industry. But in principle, now it's broadly used for research procedures for any advanced technological research and commercialization, industrialization. So it can be divided, it has 9 levels from basic principles to actual system proven in operational environment, and 2 and 3 sub-blocks: research, development, and deployment. So the first 2 stages that I was talking about on previous slides, they broadly fall into the research phase of this approach. So, and here we are very advanced, and I'm very glad to inform you that for these 4 countries, we are actually getting close to achieving the level 3. So the final stage of the research component of the scheme for NUTEC Plastics in pilot countries. So it's the experimental proof of concept. So after this, we basically are able to show that our technology is operational, that our not technology is operational, but that it is feasible. So that what we are doing, it works, that really the properties of the materials are improved, and we can go ahead with the recycling plastics with the use of the proposed technology. So we expect this to be done in all these 4 countries. And this is based on the update from February 2023 on the project coordination meeting that we held back then a month ago. And tomorrow, by the way, we're having the next project coordination meeting to discuss how we are moving with this. The idea that by the end of Q1 for some countries and for the Q2 in others, we'll already have this experimentation phase, that experimental proof of concept will be done. I am very glad about this progress, and in principle, when I took over this project, I never expected it will be moving forward so fast, and this is achieved due to the great commitment of our research teams in all 4 countries. For the stages 4 and 5, it will be already development. So this is what we expect to do, let's say, from the middle of this year. So we expect in some countries to achieve level 4 maybe by the end of 23, and level 5 by the end of maybe year 24, but it obviously varies how they progress. And here the most important part is to find the industrial partnerships, because we're already in the development stage. We need to test technologies at industrial scale, so not only in laboratories but in relevant environment. So for us, the main challenge now, and basically we find quite a good solution, I think, for this challenge, is to find the industrial partners, companies that would be ready to move forward with testing the technologies that were developed at research phase in their facilities. So then we are planning to move towards the technology demonstration in the environment, and then potentially the refurbishment or construction of the new power plant by the end of 2025. A few words about each of the pilot countries, so that you better understand what they are doing and where they're standing at. So for Philippines, they plan to reach this technology readiness level, TRL3, the experimental proof of concept, by Q2 of 2023. I know that the team from the email exchange from last week, they are working very hard on finalizing some experimentation, and they've got some very promising results. So I really hope that this schedule by Q2 2023 will really happen. Like tomorrow, I'm expecting the report from their side, so probably I'll have more details on how things are going and whether they managed to find solution for some challenges they faced at early stage of development. Their project, what they're doing, what they're trying to do is to process plastic waste through irradiation and clearly to enhance their physical properties, what I was talking about before. So the goal is to produce housing construction materials, for example, tiles and bricks. And this is the challenge. For example, in Philippines, currently you cannot produce tiles and bricks from plastic material, recycled plastics, because the quality is not good enough. So with irradiation, we should be able to do that. Philippines already have really advanced cooperation with research entities in the country, for example, with Industrial Technology Development Institute. But the most important part is that they have an established industrial partner, Envirotech Waste Recycling, that is really committed to introduce this technology in their production process. So here, I hope within a couple of years, we'll be able to get this refurbished advanced or new plastic recycling plant with EnviroTech. EnviroTech already provides the research team with necessary plastics, different types of used plastics for experimentation for recycling. They are not located in Manila, they are located on other island. So probably the plant and the facilities will be located on that island in Philippines. And now you can see the project Gantt chart. This is the plan, the current one, for where we are going to be with different stages, like TRL3, TRL4, TRL5 by months. We update to those Gantt charts for our coordination meetings every month. So this allows very strong control and, I would say, a review about the progress of each research team, not only Philippines, as everybody is doing this. The second country I would like to talk about is Malaysia. So Malaysia actually implements two sub-projects. So first is recycling of PTFE with the use of irradiation. And this is at more advanced stage because they launched it first. And here we also expect TRL3 by Q2 of 2023. And the second block is about plastic radiation pyrolysis. It's the new one, and it's based on the interest of industrial partners. So this actually is very encouraging because in this case, industrial partners reached out to the research team and asked them to conduct research in this field due to the interest of the industrial partner, their needs for their industrial process. So for this activity, the idea is to convert and enhance mixed plastic recycling, basically, that the industrial partner is working on. And here we expect TRL3 later, by the end of this year, again, because the project was started also at a later stage. I'm very glad about the advanced level of progress on recycling of PTFE. I was in Malaysia myself in October, so overseeing the laboratories, facilities, conducting national stakeholder meeting. So I really have strong hopes about the progress of Malaysia, for particularly post-TRL3 and for industrial scale. For this, they need advanced equipment. And the agency is trying to provide support, for example, to get the jet mill for them. Because at first, a Malaysian research team needed a small one, but it took time due to COVID and so on to get this one to them. So now we are trying to get an industrial scale jet mill, and this would allow them to conduct experimentation and later also work with the industrial partner at significantly higher level. So this is the priority for us. Like, I mobilized some funds for this, and I think we are moving forward with this pretty well. Indonesia. For this, TRL3 is also planned by the Q2 of 2023, and the project is to develop a compatibilizer that can be used for wood plastic composites, again for construction, made of recycled polyethylene. And the current status, we have really promising results about the surface properties of these polymers and compatibilizers after radiation treatment. And this is also followed by heating treatment, but at the lower temperature. Again, we had the national stakeholder meeting in Indonesia, also in Q4 last year. I was there. And there is an interesting industrial partner, Viro company, that is producing these wood plastic composites and uses recycled polyethylene. So they are very interested, and they, for example, showed us the facilities where they produce it, but also the places in Jakarta where their products are being used. So I really hope that this partnership will move forward and will be able to inject in their industrial processes our technology. Also, during my visit to Indonesia, BRIN, National Research Agency, and the University of Indonesia signed a letter of intent on collaboration on this field. So they're also planning to work together. Thailand, the last one from the 4 pilot countries. We have 2 sub-projects for Thailand, again, same as for Malaysia. First is the recycled HDPE pellets made from discarded fishing nets. So this, for this one, TRL3 is expected by March 2023. So I hope that maybe tomorrow they will inform me whether they will be able to get this proof of concept done by the end of this month, or they need maybe April or something like this to finalize experimentation. And this is a focused modification of the project, because before they were trying to work with more different types of plastics, but I find this specialization, this focus particularly interesting because it directly touches the issue of marine plastic pollution, because we're talking about fishing nets here that are made from plastics. So in this case, this old used marine plastic nets, they won't be just discarded, put in landfills, or go back to the ocean in worst case scenario, but they will be used for the production of HDPE pellets. So, and this clearly also directly touches the issue of the SDG number 14 of life underwater. So like here, I think the direct connection between the block of NUTEC Initiative for marine plastic monitoring. And the second block is the newer one. Again, it's on wood plastic composite, and it's a newer initiative that is based on discussions of me and the technical officer of the project on the enhanced collaboration between national research teams. So in this case, we expect the technology readiness level 3 by the end of this year. And here the idea that for wood plastic composites, they are important for all the countries, for all pilot countries involved in the project, that they should work together more. So like in this case, they can proceed quite quickly because they can share their experimental data and also share the information about the approaches they use. So I really put a lot of hope in these activities, in particular about the collaboration. So the challenge here is that if countries, like if their research teams have the partnerships with industrial partners, for them it would be a bit hard to share some data that could be commercially sensitive. We understand that, and obviously we're not pushing them to do this. However, in their case, I strongly hope that at least some information, some approaches could be shared. So like all 4 pilot countries could move forward faster. So they would be able to get those wood plastic composites with the use of radiation technology at quite quickly. So by the end of this year, maybe a little bit later. So because the demand for this is potentially could be very high. So like here we could really use a lot of plastics that could be recycled. Yeah. So like this is potentially a huge market, like for example, much higher than for discarded fishing nets. And this could be sort of a game changer in Asia and the Pacific region, but also globally. A few words just to summarize what was going on in the last year and what are the plans for this year. We're organizing the national stakeholder meeting, so exactly to get industrial partners for each of the countries to work with them and to move to technology readiness level 4 when you start testing, not only in laboratory, but also in industrial environment and potentially in operational environment. So we organized 2 in Malaysia and Indonesia last year in October 2022. And both of them were actually, colleagues, very successful in my view, because in both countries, we managed to determine industrial partners. In the case of Malaysia, I think even 2, and now the 3rd one is planning to join. So I didn't expect this direct result so quickly and like in such a straightforward manner. So it's a lot because of the motivation of national teams, how they were promoting their work, but also we can see here the interest of industrial partners. So business is somehow interested in what we are doing. Then we are planning to have national stakeholder meetings in Philippines in September of 2023 and in Thailand in October, potentially. So I hope it will also help them to get additional industrial partners, because as I said, Philippines already have 1, but maybe more will join, and that would be good. Yeah, so when you diversify, when you hedge your risks, for example, you work with a few companies, that would be much better. Then we organize regional training courses. So the first one was organized in Indonesia in October 2022, and it's particular on the progress of from technology readiness level 3, so from this experimental proof of concept to technology readiness level 7. So when we have already the first industrial facility, the pilot plant operational. So we are analyzing what countries are doing, how they could do it, and how long it could take. So I think that was useful for them, because in principle, we developed the plans for each country, how they could proceed, how they could progress. And not only for four pilot countries, but for all 10 of them, because they were reporting even those that are at earlier stages on how they would achieve the more advanced stages. Then we also plan to have in Thailand the second regional training course in October of this year, particularly on the use of low to medium energy beams for polymer modification. Because currently we normally use high-level energy beams, but we have, again, this may be problematic technologically and financially for some countries in the region that do not have enough advanced capacities. Yeah. So for them, low and medium e-beams could be a solution. And we are trying to show that in principle, they can also be used at industrial scale. So this could be also a significant solution for many countries in the region. Again, would really help to spread the technology broader, even for the countries with a limited national capacity. Then what I'm trying to do is to organize midterm project coordination meetings on an annual basis. Well, for previous years and before I joined this project, it was not possible because of COVID, but I'm trying to get together all the national teams again, so that they exchange their knowledge, information, their plans, motivate each other and move forward at increased speed. The first one was organized in Indonesia in October of last year. We got together all national teams from all 10 countries. And the next one is planned in Thailand in October of this year, so exactly 1 year after. I hope by that time in October, we already definitely have technology readiness level 3 in pilot countries, with them starting technology readiness level 4, so testing at industrial scale. So this, in a nutshell, the plans for this year. Thank you very much. This concludes my presentation. I would be very glad to take questions from your side. Thank you, colleagues, for your attention.
Dennis, thank you very much. A lot of information there. And I think certainly from my side, the fact that there is technology which can help us recover degraded plastics. Certainly one of the big challenges we have are plastics that have been in the environment for extended periods of time, have degraded, and as such are not really suitable for other recycling operations. The IAEA, the NUTEC technology and its ability to try and recover some of those structural properties, I think is a fantastic opportunity. We do have a couple of questions in the chat. So the first one here is from a colleague in India. Is there any pilot being planned in India? And also, at what stage do you expect to reach commercial operations for these various NUTEC technologies?
Oh, in India, we do not have, I think, because India is not the part of the project. In this case, we have teams from Sri Lanka participating and from Bangladesh, but India did not join in this case. Clearly, India is most welcome to join this activity. It would be great. But India is not the part of technical cooperation program of the IAEA, so it's more seen as donor or somebody neutral. So like their participation would be formatted a bit differently. Yeah. So India is considered to be a more advanced country, but we will be very much welcome their participation, their involvement. They'll be interested about this. And can you repeat the second question?
So the second part of the question was, at what point do you expect commercial operations to be achieved from these various technologies? So I suspect TRL level, 7, 8, 9.
Oh, in best case scenario, I hope should be 2026. Yeah, so like this is our goal. Like it's best case scenario. We are working on achieving it. In principle, here and there, it's not so simple. Yeah, like sometimes we're a bit lagging behind. This is why I tried, for example, to introduce this control on monthly basis on how the countries are proceeding. But the idea is still to do it by 2026, maybe 27.
Excellent. And just a quick follow-up question. Somebody's asked about expanding on your work in Bangladesh. Just a couple of minutes, or just a quick reply to that. And then we've got a much larger question about HDPE pellets. So yeah, please, Bangladesh.
Oh, Bangladesh is not a pilot country. It's at the earlier stage. So it's like technology readiness level 1 and 2. I had a meeting with the Bangladeshi team in Indonesia in October of last year. Actually, they are very good. So the research that they are conducting is impressive. They are very dedicated. So I hope that we will be able to support them more, like to provide them with more additional equipment they need for experimentation. So they also get faster to technology readiness level 3. As scholars, I think they are good and what they are doing makes sense.
Okay, excellent. Thank you very much. So we have a larger question here from Natalie. For the recycled HDPE pellets made from discarded fishing nets, how would the irradiation technology help with the recycling? From my understanding, it's been a challenge to recycle fishing nets as they're usually made of mixed plastics. Would it be possible for you to explain a bit more on how this could aid the recycling process? So quite a specific one there.
Yeah, quite specific, I agree. So in principle, that's how and why nuclear like radiation technology is so important. Yeah, because with irradiation you can do this scission, oxidation, and so on reactions that I showed during my presentation. So in some cases you cut those polymers in shorter ones, yeah, and some like you change their structure. And with the use of like different intensity of E-beams, this changes their physical and chemical properties, even though they are made correctly from mixed plastics. So that affects them, and you can change the properties of the plastic that are being used there to more uniform stage, and then you can recycle them. So in principle, you kind of add the additional technological stage to the whole process when you try to recycle them. Now it's not convenient, now it's complicated, so you normally don't go for their recycling. But the use of radiation, the properties of these mixed plastics that are not the parts, like being the components of the network, fishing nets, I suppose that would be more correct to say, they change and they become recyclable.
Excellent. Thank you very much. Are there any other questions? We're getting close to the end of our hour, but I think we've perhaps got time for one more. Could those plastics be recycled many times? So after we've recovered the plastics, we've used some form of irradiation to help stabilize it. Does that then allow it to become fully circular, or can it be recycled again?
It should be recyclable again. So we hope that when all of this industrialized, operational, with technology readiness level 7 pilot plant, we show that it works, then we upscale to multiple plants, everything should be recyclable multiple times. So really the big stage towards fully circular economy. On our publication that I think was published last year, particularly on Asia and the Pacific region, one of the main focuses is about the circular economy. So like really make completely sustainable, completely circular use of plastics. I mean, it's a big vision, obviously, but that's the goal.
We have a hand up from Steve Peters. So Steve, please ask your question.
Yeah, thanks, James. Hi, Dennis. Just to let you know, ADB has an existing MOU for collaboration with IAEA. One of my colleagues, Dr. Nam, is actually an ex-IAEA staffer from Vienna.
No, I know him.
Yeah, so Nam sits about 20 feet from me here. We met with your team previously. We didn't hear about this, funnily enough. We heard about some of the atomic energy work you're doing. ADB is barred under its charter from doing any work on atomic energy, but we do a great deal of work with you on isotopes and nuclear medicine. So it might be worth exploring how this could be worked into that current work plan, just to let you know. Okay.
Great. Well, in principle, well, that was me and my supervisor, Gashav, Mr. Wolde, who is the head of our section for East Asia. So I met with them when we were visiting ADB in October. I think we talked a little bit about plastics back then as well, and I know that we are working on the MOU and practical arrangements. I think
good.
That's great. Expected to be signed between the IAEA and the ADB. I hope quite soon. So like clearly, I hope that the block on plastics is there, that we can work more on this.
Good. James and his team are the people to talk to about plastics. They are the gurus. So I'll leave it to you. Thanks, James. Thank you for the presentation.
Great. Thank you very much, Steve. And I think, Dennis, that is the end of our hour. Thank you, everybody, for joining us. Thank you, Dennis, for a very interesting and comprehensive presentation, and for picking up on Petra's section on the oceans and covering that for us. We do appreciate it. So thank you very much, everybody. I do encourage you to keep joining us on our webinars. Have a look at the recordings of the previous webinars, and you can reach out to our organization team through the Circular Economy email address if you want more information, or if you have any questions which you wish Dennis to answer after the webinar is finished. So Dennis, once more, thank you very much for joining us. Thank you for your time. Everybody, thank you very much for joining us, and we look forward to seeing you again next time. Thank you very much. Bye-bye.
Thank you very much, James. Colleagues, contact me anytime if you have any additional questions. I think James would be able to share my contacts with you. So I'll be glad to reply on anything, and my colleague Petra as well, because she's a main specialist on marine plastic monitoring. So we're always here. We'll be very glad and interested to collaborate with you further. Thank you.
Thank you, Dennis. Thank you, everybody.